Welcome back to the channel. I hope you guys are doing really well. So Merry Christmas and an advance Happy New Year to all of you. I am back to making the daily challenge videos after a long break from my vacation. So yeah, from today onwards, I am resuming to make daily challenge videos of Leetcode. So let's see the problem statement today, and let's see how to approach this problem. Okay, so there is a one based binary matrix where 0 represents the land and 1 represents water. Okay, and you are given integers row and column representing the number of rows and number of columns in the matrix. Initially, on the day 0, the entire matrix is land. That is, the entire matrix is filled with only zeros. However, each day a new cell becomes flooded with water. You are given a one base 2D array cells where cells of I is nothing but row comma column. So it just tells you cells is nothing but a vector of pairs, and each pair gives you a particular coordinate. And it tells you that on the ith day, this row Ri and column Ci gets completely filled with water. That is, it gets covered with water. You want to find the last day that it is possible to walk from the top to the bottom by walking only on the land cells. And you can start from any cell in the top row and end at any cell in the bottom row. You can travel in 4 cardinal directions: left, right, and up and down. Okay, so return the last day where it is possible to walk from the top to the bottom by walking only on the land cells. So you can look at some good example. So look at this example number 3. In the day 1, this all of these 3 cross 3 row is 3, column is 3. It means that it is a 3 cross 3 matrix, and the whole thing is land. That is, the whole thing is 0. On day 1, what happens? The coordinates 1 comma 2 gets filled with water. You can see here, right? Still you can walk from this top to bottom. Okay, and in the next day, this another coordinate gets filled with water. Still you can walk on the land. And when on the next day this 3 comma 3 cell also gets filled with water, what you can do, you can find a path to reach the bottom row from the first row. Okay, so that's why it is still possible. And in the last possible day, you can see 2 comma 2 also gets filled with water, and in no way you can reach the last cell, given that see, you cannot move diagonally, you can move only uh, sideways and top and bottom. Okay, so yeah, that's how you can move. So one thing is very obvious. If you try to think of a very brute force solution to solve this, you will be telling that, hey, when every cell will come, I will just make it filled with water, and for every cell of the first row, I will see whether the last row is reachable or not. But that will give you a TLE for obvious reasons, because if you look at the constraints, row and column individually are 2e4, and the product are also 2e4. But yeah, if you traverse in each and every cell, see the cell size, the cells dot length is also row into column, right? So it is also 2e4. So for each of the 2e4 number of operations, you cannot perform a 2e4 order of operations, because it will give you 4e8, and that will give you a TLE, right? So how can you solve this problem? Uh, One thing you can do is that, see, cells is exactly row into column, right? So if there are 3 rows and 3 columns, number of elements in these cells will be 9. It means that at the end, everything will be filled with water. Okay, so you see, you are given basically various days, right? So let's say in day 1, some particular cell gets filled with water. In day 2, some another cells get filled with water, and so on. In the last day, all the cells will get filled with water. It is guaranteed, because the length of this array is nothing but row into column. Okay. Now, what you want to find is that want to find an optimal day I, where if these many cells are filled with water, still you can find a way to reach from the first row to the bottom row by traversing only on the land areas. Okay. Now, quite obviously, you can use a BFS traversal to find that any cell from the first row, if it can reach any cell from the bottom row. But what is the time complexity of that? This is of the order of whole cell, right? If this is n and m, the time complexity will be O of m into n. row into column, which is nothing but 1e4. So that you can do it 1e4, right? And you can also construct this whole matrix. So if I give you any day I, let's say if I give you a day I, starting from day 1, day 2 till all the day I, what you need to do, you need to make a grid which has all the land initially, and for each of the day you will get a coordinate, you need to make that one. Let's say you get in the second day you get some other coordinate, you may need to make that one. Okay, so till if I give you a day I in O of, again in O of this I number of operations, and I can go up to row and column, you can again in O of n into m operations, you can tell me that what is the status at day I. Okay, so status at day I can also be found out in O of n into m. That is, you just, it's basically O of I. Okay, and I can go till the row into column number of elements in this. So that's why I'm telling O of n for the worst case. So yeah, so at a particular day I, you can tell me what is the status in O of n into m. Also, you can tell me that if there exists a path in O of n into m. Okay, these two things are done for now. Now what they are asking is that what is such optimal day? Okay, so you need to find an optimal day after which it is not possible. Okay, so let's say if I'm, let's say I denote 1 if it is possible to go from first row to the last row, if it is possible to go from the first row to the last row, and I tell 0 if it is not possible. Okay, okay, not possible. So what I can do is that hey, I have a vector of pairs, right? So let's say my optimal day is some day I, and at day last I have all filled with water. Okay, so if everything is land, I can definitely go from top to bottom, right? So I can say that this is possible. Okay, this is always possible. So for this, my coding will be 1. This coding I have done, if it is possible, then at day I, this also 1 1 1. At day I also it is possible, and at, let's say, day I plus 1, it is not possible anymore. Not possible, not possible, not possible. One will be not possible because all the cells are covered with water, right? So uh, I need to find this optimal I where this transition from 1 to 0 happens. Now, very obviously, if you can get this kind of pattern, you need to do binary search on answer. I have told this multiple times in my video. Okay, if you can see anywhere this kind of pattern 1 1 1 0 0 0, or some patterns like 0 0 0 1 1 1, if you can do some coding like this in your problem statement, definitely that is a binary search on answer problem. This is a little bit different from normal binary search. I hope you already know it. If you do not know, you can see some of my binary search uh, video. Okay, so you can go to my playlist and see some binary search videos, binary search on answer. You will get very clear on how to do this. So continuing this, what do I want to do is that I can put my L, I have two pointers L and R, let's say over here, and I will find a mid every time, which will be L plus R by 2. This is the standard thing which we do in a binary search. Okay. Now, if this mid is 1, then I will shift my left pointer. Now, if this mid is giving me a 0, I will shift my right pointer. And in that way, I will be ending up in having L and R in this manner. Okay. In this 1 and 0, and I will simply return L. Okay. So I just need to see. So you do understand, right? What is our objective? Objective is finding the optimal index, or I can say that finding the latest index where crossing is still possible. Okay, where crossing is still possible. So I hope that is clear to you. I guess we can start the coding, and if you are feeling a little bit comfortable right now, okay, you can start the coding portion on your own. Definitely we will, to get these zeros or one, we will write an is good function which will, or is possible function which will tell me whether it is possible to go from the first row or first row to the last row. and it will again return either 0 or 1. And using this function only, I will update my binary search pointers. Okay, so yeah, let's see what we can do. Yeah, if you think you can't solve it on your own from now onwards, you are definitely free to drop off from the video and do the coding portion on your own. Yeah, if you require some help, definitely stay with me. So uh, what all things we want in our binary search? We want a left pointer. Let's initialize to -1. You can also, I guess, initialize to 0. I'm doing it -1. uh cells dot size, I can make it. Okay. And what I will do while l plus 1 is less than r. Why I did this? Because I want to stop at a point where 0 and 1 happens, right? So 1 1 1 1 1 1 and 0 is zeros are there. So this is l and this is r. So if l plus 1 is less than r, then only you keep shifting your pointers. If this is not true, so in this case it is not true, then that is the stopping criteria. Okay, that is our stopping criteria. So we will calculate the mid value, which is nothing but L plus R by 2. And yeah, I will write a good function if it's good. Okay. What will be those values? It will take an M, talking of the index, and it will take row, it will take column, it will also take the cells. It will what this function will do. What this function will do? First of all, it will create a grid matrix by placing the water cells in its appropriate positions. Then it will perform a BFS O of m into n plus O of m into n time. In this time, it will just perform a BFS and tell you whether it is possible to reach from the first cell, first row to the last row or not. Okay, so I hope this is very clear. And yeah, so uh, if it is good, what you will do, you will shift your left pointer if you are still in the 1, else you can shift your right pointer. Okay, and at the end, you would want to return the left pointer. But wait, here in the question, it is asked the till the day number. Okay, now if you just return the left pointer, what will happen? If we are returning the index, right? So this is day 1, this is day 2, and this is day so on till day I plus 1. So if l equals to I, the day number is I plus 1, right? So you can just return, instead of l, you can return l plus 1. So yeah, that is there. And you can just go on writing the is good function. So it will return a boolean value, uh, is good. Okay, it has an integer m, it has an integer row, it also has an integer column, and yeah, it has cells. Okay, so let's see. uh, okay, so we have this mrc as well as the cells. And uh, what you want to do here is, at first you want to create a vector grid, right? So the grid we are not having with us right now, so we would want to make it. Initially, everything is land. Okay, so you can just fill it all the cells with zeros. And if it is land, I want to populate the water one by one by traversing through the cells. Now for I from 0 till what we will go till m. Okay, I want to check that this is nothing but that index I which I was talking about, and I will just check whether this index I, if we see till this index I, whether we have any path or not. Okay, whether we have any part or not. So what will be grid? It will be nothing but cells of uh, I0 minus 1, since it is a 1 based indexing told in the question, and cells of I1 minus 1 again will be equals to 1. So it tells you this this coordinate of x and y is filled with water. Okay, if it's filled with water. Now, now definitely you want to do a BFS. Now, what are the standard things for doing a BFS? I hope you already know a BFS. I am not telling you again what is BFS. And also you need a queue, and for doing BFS on a grid, you definitely need a pair, right? So pair integer comma integer queue. What are all the things that you are going to put in your queue? You are starting from the first row, right? So any cell you get from the first row, you want to push it in your queue. So what you want? You are traversing from this row to this row. Let's say this is water, but the remaining are land. Okay, so you want to push all the remaining cells which are in the land into the queue. Okay, because you can start your BFS traversal from any of them. Okay, you can start from any of them, right? So that's why you will just push. If what you can do, you can go through. You can have an iterator I from 0 to C, and you can check if this grid of 0 comma I. Okay, this if this is 0, uh, it means that if this is land, then push in the queue. Okay, what do you want to push in the queue? The coordinates, the zero based indexing coordinates. Okay, yeah, you just push that, and now you can start the normal BFS, I guess. So while queue is not empty, you can go ahead while queue is not empty. See, I am assuming that at least you know how a normal BFS templates look like, or how it works uh, in general. So yeah, and see, you are allowed to move in 4 directions, right? So uh, yeah, for BFS on grid, this is a standard thing. But if you are on a cell I comma j and you are allowed to move in these 4 directions, this will be nothing but um, I j plus 1. This will be nothing but I j minus 1. This will be nothing but I minus 1j. This will be nothing but I plus 1j. Okay. So what are the things which you are adding? See, you are in I comma j, you are adding 0 comma 1. You add 0 to I, it remains I. You add 1 to j, it remains 1, right? So this is the trick. You adding 0 comma minus 1 here, you are adding minus 1 comma 0 here, you are adding 1 comma 0 here. These in this way you can obtain your adjacency. I mean, you can obtain your um, adjacent cells. Okay, so you can traverse through this and obtain your adjacent cells. So vector of vector, you are having direction, and 0 1 0 minus 1 1 0 minus 1 0. Okay, so yeah, you are having these directions, and integer, uh, first of all you have the x coordinate, which is nothing but q dot front, the first and the first. Okay, since this is a pair, it's the first one. And for the y, it is nothing but q dot front and the second. This is the standard thing which we do in a BFS, right? And you also do q dot pop, and you want to return if return true if you see that this x is ever r minus 1. Okay, so this x coordinate, what does it mean to reach the end of the cell? Okay, to reach the end row is having the row coordinate to be the last one, and row coordinate is a one based indexing, right? It is given in the question. So if the x coordinate, that is the row coordinate, reaches to be n r minus 1, and so then you can tell that return true. From the whole is good function, you can return true because you have found land which is there at the bottom, at the last row. Okay, and if you cannot do anything even after this whole while loop, you can return false. Now definitely you want to do an adjacency matrix. Okay, uh, you want to go to the adjacent cells, so there can be 4 possible adjacent cells, right? And they are denoted by, let's say, x1 and y1. Okay, okay, so now if they are x1 and y1, what are they actually? They are nothing but 1 plus direction of 0 I0. You do get it, right? You are just adding this whole thing to get your new adjacent cells. So this is nothing but y plus direction of I1. So once you get x1 and y1, you want to check whether this x1 and y1 is still lying in the grid. So what is the criteria? What is the criteria that you will put to check whether they are still lying in the grid? They must be greater than or equals to 0, and x1 must be less than r, and y1 must be again greater than or equals to 0, and y1 must also be less than r. And there's another criteria, that must be a land. Okay, you cannot step on a water, right? So that must be a land. So what you can do is that grid of x1 y1, you can see if it is a land. If it's 0, then only what you can do q dot push uh, x1 comma y1. Are we missing out something in this whole implementation? Yes, definitely. We need a visited matrix, right? So I hope if you know about graph traversals, yeah, I hope you know about BFS since you are doing in this problem. So you need a visited cell, because if you have just now gone from this cell to this cell, you do not want to visit it back, right? You want to go forward, and so you want to mark the visitor. So there is a trick here. Instead of having a separate visited array, what you can do is you can mark grade of x1 y1 as 2. This will denote that it is visited, okay? And here also you must remember that when you are pushing elements in the queue, it means that you are have already visited that, okay? So mm grade of x1 y1, that will be 2 again, okay? And it will only push if you have not visited and it is a land cell, okay? So 0 denotes it is not visited and it is a land cell. 2 denotes it is a land cell but it is visited, okay? So yeah, so you have it with you, I guess, and this should work just fine. There might be some, okay, so yeah, this will be C. Okay, so there might be some errors, but let's try to run it and check if it works, and we will do some debugging. Uh, okay, so do we have an undeclared identifier over here? Grid, okay, so this is not x1, y1, right? This is 0 and 1. This is just that portion of the grid. So yeah, let's see after this. Yeah, we have the accepted thing. You can see it right now. If we try to submit and see if it works for all test cases or not. Yeah, it does work for all test cases. We have an okay type of runtime complexity too, and I hope you did understand the problem. And if you know how to apply binary search on answer, as well as if you know uh, BFS on this matrix, this should not be a very difficult problem for you. So yeah, that's all. Even if you were stuck in this problem, I hope it is now very clear to you. And yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.